two of those in our examples. So, what does a radical look like? Yeah, there we go. Morgan's doing it. Little check mark, but everyone always calls it a check mark, right? Your square root is a radical, but you have other radicals other than just a square root. You have your cube root, your fourth root, your fifth root, whatever root you want it to possibly go to. So here are some basic roots. Now we're kind of bypassing the square root because you guys have been doing square roots since freshman year, maybe even middle school. So you should be able to do all of your square roots and your perfect squares. But do you know your higher roots? So if you are asked to simplify the following radicals, so part A is asking you for the cube root of 64. So remember with square roots, you're trying to think about what number times itself gets you to that. So like the square root of 49 is 7, because 7 times 7 is 49. The square root of 36 is 6, because 6 times 6 is 36. So I'm looking for a number that multiplies twice. Because it's a cube root, I'm looking for a number that multiplies 3 times. So what number 3 times itself is 64? 4, right? 4 times 4 is 16. 16 times 4 is 64. So the cube root of 64 is 4. What would be the cube root of 125? 5, because 5 times 5 is 25. 25 times 5 is 125. Fourth root of 16? 2. Yep, 2 times 2 is 4, times 2 is 8, times 2 is 16. And what's the fifth root of 32? 2 also. 2 times, because another 16 times 2 gets you there. Now, your calculator does this very nicely for you. Does anybody know how they can do this on their graphing calculator? Get your graphing calculator out. We're doing some trig there. Now, depending on how your calculator is set up, like if you have the old school TI-83, and I want it to take the fifth root of 32, I would have to first type in the 5 and then go to this button and then hit 32. But on my calculator, it just gives me the blanks. So if you go to your, I think, is it my math button? Let me see where it is. I got to remember. Oh, there it is. It's right there staring in front of me. Thank you. Thanks, Kayla. Number 5. Okay, so number 4 is your cube root. So if you wanted to find the cube root of anything, you could just jump to right to number 4. But then number 5 is your nth root. So you need to pick whatever it is. So if I click on number 5, oops, I have to put the number in first. So 5, I'm doing the fifth root. And then I would hit math number 5 of 32, and it gets me to 2. Is anybody's calculator giving you like a little blank box? Yeah, I guess mine's not doing it for that. Okay, so the fifth root of 32 is 2.
Sorry, you said the 83 should be different, right? Because
yes, well, you would do the same thing like I did here.
Okay.
So if I wanted to do the fifth or the fourth root, so I would hit 4, and then, I don't know why I keep hitting second, math 5 of 16, then it would get me 2 also.
I just wanted to make sure. Cause
Are you getting it?
yeah, I got the same answer doing
right.
that. So I was...
Yeah. Okay. I was thinking that this would give me a little bubble, but I guess it's the fancier calculators that probably do that, where it gives you like a little bubble actually right here, and then a bubble, so then you can actually input a number. And is yours doing that? No. Probably like the ones that the chargeable calculators do that. Okay, anyways, so your calculator can do as many roots as you want it to do for you. So now let's go over what the different rules are for the nth root, depending on what's happening. So when we have the nth root, meaning whatever number I want to plug in for n. Rule number 1, if n is even, and A, which A is just the number underneath the radical sign, we call it the radicand, and A is positive or 0, then the nth root of A represents the principal nth root of A, which is exactly what we've just been doing. So if n is even and A is positive or 0, then the nth root of A represents the principal nth root of A, meaning the square root of 49 is 7. 7 would be the principal squared root of 49. If you have a negative in front of your nth root of A, so the negative nth root of A, then that would represent the negative nth root of A. Meaning all you're going to do is just put the negative in front of it. So if I was taking the square root of 49, that would be 7. The negative of the square root of 49 would be negative 7. So it would be the negative of a positive 7. Okay, so if n is even, then A needs to be a positive number or it needs to be 0. You can have a negative in front of an even root. We just can't have a negative underneath. Does everybody have this written down? All right, because number 2 says if n is even and A is negative, then the nth root of A is not a real number. That's when you get into imaginary numbers, if you guys remember that from last year. We're not there yet. Okay? So if n is even, meaning your index, your root, square root, 4th root, 6th root, 8th root, and you end up with a negative number underneath, then you are going to have no real number where you're simplifying. Can't happen. Okay? All right, so what you're going to be asked to do here is simplify some radicals. Again, we're keeping this really basic. It's not going to be that complicated. So if number, here, hold on, let's go to these first. So the square root of 100. Square root of 100 is what? 10. Good job. Nice job. All right. I don't even know why I have these in different ones. Let's do another one. Let's do the 4th root of 81. Yep, it is 3, because 3 times 3 is 9. And then if you did another 3 times 3, that would be 9, and 9 times 9 gets you to 81. Yep. What if you had the negative of the 4th root of 81?
Would it just be positive 3 because it's an even number exponent?
Well, so the 4th root of 81 is 3, but I want the negative of that, so it would just be negative 3. Yep.
So if it has a negative, we would just get the regular answer and just throw a negative in?
Yep.
It wouldn't matter.
Yeah, because it's kind of like taking a negative times the 4th root of 81. But if you had...
Parentheses?
Huh?
Think like parentheses?
Kind of. It's kind of like taking a negative 1 times the 4th root of 81, ultimately, is what you're doing. Right? If you had the 4th root of negative 81, we cannot do that. So we would say no solution or no real number, whichever you prefer is acceptable. Okay. But if you had something like this, let's make an E. If I did the square root of negative 7 squared, it would be 7, because negative 7 squared is 49, and then it would just be 7. So here a negative is underneath my radical sign, but the whole thing's being squared, which makes it go to a positive. So I can actually physically get a solution, instead of unlike in D where it's a negative. Okay? So if it is even, you have to have a number that is positive or 0 underneath. You cannot have a negative. And then you can go about your business as usual. Where it gets different is when it's odd. So for our third rule, if n is odd, then there are no restrictions. So then there is exactly one real nth root of a, which is written as the nth root of a. So if you think about it, if you multiply a negative times itself an odd number of times, does it result in a positive or a negative? For example, negative 2 times negative 2 times negative 2 would be negative 8, right? So you can end up with a negative answer when you're taking a odd root of something. If you were doing negative 1 times negative 1 times negative 1, that's negative 1. So the cube root of negative 1 is negative 1. Okay, so let's just go through some here quickly. I'm just going to do them all on the same page. Where were we at? F? All right, so if we had the cube root of negative, let's do 27, what number times itself 3 times is negative 27? Negative 3. So negative 3 times negative 3 is positive 9. 9 times negative 3 is negative 27. If I had to take the cube root of a positive 27, that would be positive 3. If I had to take the negative of the cube root of positive 27, what would my answer be there? It would be negative 3, right? Because the cube root of 27 is 3, but then I want the negative of that, which would be negative 3. If I flip it and make it the negative of the cube root of negative 27, what would that answer be? Positive 3, right? So the cube root of negative 27 is a negative 3 times another negative makes it become a positive. Okay? So anything with an odd number, you can either get a positive or a negative. If you had the 7th root of, where are we at here? G, H. Did I go backwards in my, I have double G. Man, where are we at? J. If I had the 7th root of negative 128, any guesses? How?
Well, actually, I have a question. So if it's even and there's a negative in there, it becomes not a
Correct. You can't do that.
But if it's odd and there's a negative, you still go throughout the
Yep.
whole definition.
Yep, because when you have an odd index, because this is the index, you can multiply a negative out an odd number of times and still result in a negative. Who's got this one? Negative 2. Yes, it is negative 2. Okay. So odd indexes, you can have a positive or a negative result. An even index, then you cannot have a negative underneath. All your answers will always, always, always be positive. Okay? All right. I'm going to flash through all those. Now let's get to actual graphs of radical functions. So here we have to graph the function f of x equals the square root of x minus 3. So my index in this case, is a square root, so my index is 2, meaning that it is even. So what did I say? If it's an even index, it always needs to be positive or 0, right? Because you can take the square root of 0 and just get 0. So we need to figure out what my actual physical domain needs to be. So I need all of my values to end up being greater than or equal to 0 for underneath the radical sign. So we take whatever is underneath the radical. I feel like we did this before. So if I solve out this inequality by adding 3 to both sides, we get x needs to be greater than or equal to 3. Because if it was less than 3, if it was 2, 2 minus 3 is negative 1, and I can't take the square root of negative 1. That doesn't turn out to be a real number. So that means that my x's need to start at 3. So when I make my table of values, I need to start at 3. Well, when we input 3, 3 minus 3 is 0. The square root of 0 is 0. If I input 4, 4 minus 3 is 1. The square root of 1 is 1. If I input 5, 5 minus 3 is 2. The square root of 2, that's not a very nice number, so I'm going to skip that one. If I plug in 6, 6 minus 3 is 3. The square root of 3 is, again, not that nice of a number, so I'm going to skip that one. If I plug in 7, why would that be nice? Because 7 minus 3 is 4, and the square root of 4 is 2. All right, so let's plot those 3 points and see what this looks like. So 1, 2, 3, 4, 5, 6, 7, my x-axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 3, 0 is right here. 4, 1 is right here. 7, 2 is right here. So it's going to be a curve looking like that. Okay, so your square root or your radical root, even root, all of them will look pretty much the same. Will look like that half a turned parabola. Okay, in this case, this one shifted to the right 3. Okay, do we remember what a cubic graph looked like? So remember we had our parabolas back in whatever chapter. Quadratic graphs, end behavior, up, up. Do you remember all that fun stuff that we did back in chapter 12? Odd behavior had opposite direction, right? So the inverse of a quadratic is your square root. So that's why it tips to the side like this, but we can't have any negative versions, so we take off that half. So if I were to flip this, my cubic, or my cube root graph would be the flip of my cubic graph. So let's see what that looks like. So graph number 2, we have f of x equals the cube root of x plus 2. So is anything possible for cube or odd roots? Can I get both positive and negatives? Yes, so I don't have any restrictions. So I can pick whatever nice numbers I would like to take the cube root of.
3?
Cube root of 3 is not a very nice number. Think about your perfect cubes. So 0 is always nice.
Try
1's always nice. So I'm going to do a 1 and a negative 1. 8's your next nicest one, because 2 to the 3rd power would be 8, so a negative 8 and a positive 8. Because negative 8, the cube root of negative 8 would be negative 2. Negative 2 plus 2 is 0. The cube root of negative 1 is negative 1. Negative 1 plus 2 is 1. Cube root of 0 is 0. 0 plus 2 is 2. Cube root of a positive 1 is positive 1 plus 2 is 3. Cube root of 8 is 2. Plus 2 is 4. So So again, if we make a lazy graph, looks like I need to go out 8, both left and right. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then it's just a matter of plotting those points.
So -8, 0.
So -8, 0. -1, +1. 0, 2. 1, 3. 1, 3. 8, 4 is here. So it looks like we're getting a curve right like this. Didn't really go through my intercept there. Okay. How does your graphing calculator make your life much easier? Well, let me show you. Is everybody ready? So if I jump to my graphing calculator, and I want to see, let's do the first one. So if I go to my y equals screen and type in the square root of x minus 3, close my parentheses, I can just hit the graph button, which shows me what the graph is going to look like. So right there, and I know whether I'm doing something correctly or not. Okay. One thing your calculator does do nicely for you, have I shown you guys the table part? So if you hit second and then graph, it takes you to the table of your x and y table of values. So what's kind of nice is if you're not able to think of what the nice numbers would be to graph, notice we have errors all the way up to 3, meaning it's not defined for those negative values. But I have a nice point of 3, 0. I have a nice point of 4, 1. 5's not so nice. 6 is not so nice. 7 is nice. I could keep scrolling down to get to the next nicest point, which looks like it would have been all the way out at 12 and 3. So I could get those points very nicely for my table of values without having to do any actual mental evaluating, mental math. I did the same thing for the second function. So the cube root of x plus, it was plus 2, right? And then I go to my table. I can look for those nice points. So I know that I want some negatives because it was an odd index. So -1, 0, and 1 are looking pretty good. There's -8. I don't know how many times I hit the up button. There we go. -8, 0 is a nice one. -1, 1. And then you can get those points and see them there. And you can see the graph. Make sure your graph looks like what we made. Yeah, it looks pretty similar. Okay. All right, so those are your graphs. So the last thing we got to cover for this section is what happens when we have absolute values. So, let's skip this stuff. So if you remember, we said that when we had an even index, so if n is an even positive integer, then what's going to happen is whenever you take the nth root of the square root of a to whatever it is, we're going to need to make sure that it is the absolute value of it. And this comes into play when it's variables. Because if it was just numbers, we would already have had this taken care of. Where it comes into play is when we have variables. And you're going to need to attach absolute values to them. Okay? So it becomes a little bit of a pain when you have an even index, because you have to remember to put that absolute value in there, and I'll show you what I mean in a second. Okay, if n is odd, then it's just going to be whatever a is equal to. So if n is an odd positive integer, then the nth root of a to the n would just be a. We don't have to worry about it because it can be both positive and negative when you have an odd index. It's the even indexes that we have to be concerned about. And that's where we might lose some silly points on the quiz. Just 'cause you might forget to put absolute value signs. Okay, so this is what this looks like. So for our first one, we have the 6th root of -3 to the 6th power. Now, because I have an index of 6 here, so I'm taking a 6th root, and here I already have it to the 6th power underneath, what's going to happen is they would cancel themselves out. Now, think about this, though. Because this is a negative, what technically would happen? If I take -3 on my calculator and take it to the 6th power, oops, it's not on, -3 to the 6th power, I get 729. So this really is taking the 6th root of positive 729, right? If you did this on your calculator, you need to make sure that you put parentheses around that -3, because if you don't, your calculator is not going to take it to the 6th power. So you need to put parentheses -3 to the 6th power. So if you just do -3 to the 6th power, it's not going to take the negative and take it to the 6th power. Right now your calculator is thinking it's -1 times 3 to the 6th power. Okay? So how can we do this a lot more simply than taking it all the way out? Because then that would just get us back to 3. Because I have an index here of 6 and an index here of 6, they would just cancel each other out, and you would be left with what is underneath. But you would think, well, I'm left with a -3 underneath. But that's not so, because you're left with the absolute value of what is underneath, which would just be a +3. So you need to keep in mind, whenever I have an even index, I'm always going to have a positive outcome. It needs to be a positive. Okay? All right, so let's look at another one. Bless you. If I had the 5th root of -4 to the 5th, again, my index and this exponent are the same, so they would cancel each other out, but since it's an odd index, it's just going to be whatever is underneath, which would be a -4. Okay, so if I had, I'm just going to make up one here, the cube root of 8 to the 3rd, what would that be? 8. If I had the square root of 8 squared, what would that be? 8. If I had the square root of -8 squared, what would that be? 8. Good. Okay. So you can get your answers a lot quicker when you're doing it that way. So now let's throw in, let's skip that one. Let's go to the variables. So now we have the negative of the square root of m to the 4th. My index in this is what number?
1.
Not 1, it's a square root. So it would be 2, right? Square 2. So now I need to think about what m to the 4th square root it would be. Do you guys remember how to do this? This is what I think. I'll tell you what I think in my head. If my index is 2, I'm going to think about how many times does my index divide into this exponent. Well, how many times does 2 divide into 4? Twice, right? 'Cause technically, what m to the 4th is, isn't m to the 4th the same as m squared times m squared, which is the same as m squared squared? And since my index is 2 and I have a squared here, what am I left with? What is there? Again, what I'm thinking in my head is how many times does my index divide into my exponent? So, the square root of m to the 4th would just be m squared. Because I had that negative out in front, I need to put my negative there. Because this is an even index, I technically need the absolute value of m squared. Okay, and if you left your answer like that, that would be totally fine. The book will simplify it further, because if you square anything, won't it always end up being positive anyways? Yeah.
Alright, I kind of spaced what the exponent, so you would just subtract it, or?
No, you think how many times does 2 divide into your
Oh,
exponent?
Sorry.
So because this is already m squared, you technically don't need the absolute value signs because squaring anything will result in a positive anyways. So let's jump it up a little bit. Let's make it the square root of m to the 6th power.
M to the third.
M to the 3rd. But because I have m to the 3rd, does that necessarily mean that this will end up being a positive if I cube it? No. So I need to put absolute values around it. So to be safe, whenever you have an index that is even, I would just attach the absolute values on there so you wouldn't forget it. Because this technically, I would consider that correct. If we had the square root of m to the 8th, what would that be? M to the 4th. And then you have your absolute values. Well, do I technically need them? No, because if I take anything...
Case, 'cause it's technically not wrong.
Correct. Yes. If I had the square root of m to the 10th, that would be the absolute value of m to the 5th. Right? See the pattern? Yes, maybe so. Not so much, kind of. All right, so now let's do a cube root. Let's do the cube root of a to the 12th. So what I'm thinking in my head is how many times does 3 divide into 12? 4. So I'm going to be left with a to the 4th. Because it's an odd index, I do not need absolute values. You only need it with the even indexes. Okay?
Is this another case where we could put them up just as...
No, because you can have negatives for odds, so don't put them up for
Oh,
odds.
okay.
Only put them up for even indexes. All right. 4th root of x to the 12th. 3. So it'd be x to the 3rd. Because it was an even index, I need to guarantee that it is positive. So I'm going to put absolute values around it. Because it's x to the 3rd and the 3 is an odd exponent, it technically could end up being negative, so I would need to put the absolute values around it. All right. And that is it. So, really quickly, before I send you off on your way, I want to try some of these out. We're going to skip the easy ones. So either just say it out loud. What do we think? Square root 12 to the 2nd would be just a good old 12? Yes? All right. The square root of negative 10 squared would be positive 10, right? Because it's a square root, so it needs to be positive. The square root of negative q squared would be q, but I want to put absolute values around it. Okay, to be safe. Cube root of m to the 9th. M to the 3rd. We do not need absolute values because it's an odd index. 6th root of x to the 30th. X to the 5th. Do I need absolute values? Yes. Good.
Wait, so just the absolute value is based on the 5 or the 6?
That's 6. So if your original nth root was even, then you should have absolute values around it. Technically, you wouldn't if this was like a even, because then it would end up being a positive. But it would not be incorrect to put it there, which is what I would just do to cover my butt. The negative square root of x squared. Well, what's the square root of x squared? It would be the absolute value of x, and then just throw a negative in front of that. Good. What about the negative cube root of x to the third?
Same thing.
Same thing, do I need absolute values? No, it's an odd index, good, so just be a negative x. Last one, fourth root of k to the 20th, k to the 5th, do I need absolute values? Yes. Okay. All right, you got those? Can you use your calculator to tell me what the cube root of 0.125 is? Is everybody getting 0.5? What about the negative 6th root of 1/64? Can you use your calculator to do that? Negative 0.5, yeah. Okay, negative 0.5. So on my calculator, I would do the negative times 6 root, I keep putting second, math, 5 of 1 divides 64. Oh, I need parentheses there. There we go. What? Go to. What does it not like? Maybe I just need to get rid of that. So maybe I just need to do the 6th root of 1/64 and then take the negative of that. There we go. So 0.5. Any other ones? About the 6th root of 729. Hopefully you're getting 3. Yeah? All right. And then are we okay with graphs? What would I do for here to find my domain? I would start at what values? I would start at 5 and go along my way down. So my domain would be all values of 5 to infinity. My range is from 0 to infinity. Right? Okay? All right, so your homework are the highlighted problems out of the textbook.